Planning and design and the implementation of the planning and design continues to be a problem for many students sitting the biology examination. In this video, I am going to be sharing with you planning and design and the implementation as written by the CXC, and I'll also be looking at the mark scheme for the planning and design, also the mark scheme for the implementation. So you want to stay with me until the end of this video. If you have not yet subscribed to the channel, please be reminded to subscribe to CSEC Biology TCP on YouTube. You may also find us online at tcp-academy.teachable.com. So here we have the proposal, one might say, or the planning and design. Now, the maximum mark available for the proposal, which is the planning and design, is of course 10. And this is how the 10 marks are allotted to each section of a lab. For the observation, or one might say the problem statement or the research question, that pretty much comes. Get help with CSEC Biology SBA Labs and Human and Social Biology SBA Labs at tcp-academy.com. Tim had questions. He wanted to know where he could get help with his SBA Labs. His parents searched but could not find that experience. Tim also made some calls, however could not find the help he needed. Tim needed an experience he could trust to help him get over the hurdle of SBAs as success was in sight. He met the guys from tcp-academy.teachable.com and they designed a program to help him. tcp-academy.teachable.com was able to help him. So too, they can help you. Sign up tcp-academy.teachable.com for help with your SBAs in biology and human and social biology. Proceed all parts of the lab. For your hypothesis, you're going to be getting 2 marks. For the aim, you are going to be getting 1 mark. For the material and apparatus to be used in the experiment, you're going to be getting a mark. For the method of carrying out the experiment, and here please be reminded that the method should be written in future tense because it's something that you are going to do or someone is going to do. You're going to be getting 2 marks for the method. For the control variable named in the lab, you're going to be getting 1 mark. For the expected results, you're going to be getting 2 marks. And for your assumption or precautions or source of error or limitation, whichever it might be, you're going to be getting a mark for that. That totals 10 marks for the planning and designing. In most cases, this is the mark scheme to be used by many teachers. Now, the implementation is somewhat different because the implementation is marked out of 20. The format for this part is shown below. For the method, and this method is going to come from the planning and designing. So what you would have written in the proposal, the planning and design, that's what you're going to be doing, or you're going to be executing the lab. So for that method you wrote there, in the implementation, the method will be written in past tense now. You're going to be getting 1 mark for the method. For the results from your implementation, you're going to be getting 4 marks, and that is if it is properly done. For the discussion, you'll be getting 5 marks. For the limitation, precaution, source of error, all that, you're going to be getting 3 marks. For reflection, what is it that you learned from the encounter? You're going to be getting 5 marks if this is properly recorded. For the conclusion, you're going to be getting 2 marks. Might I emphasize here that the implementation must be marked as one of the AI lab or the analysis and interpretation. So you're going to be submitting a minimum of 2 AI labs, and the implementation must be one of those labs. Very interesting. You really want to follow me here to ensure that you secure full marks. So let's look at what's happening here. Reporting format of the investigation. So A here, we are looking at the proposal, or one might say planning and design. We're looking at the lab. Now, the statement of problem can be an observation, a problem. So, what is it that you're seeing out there that you think needs to be solved? Or it could be something that you thought about, or you would have heard somewhere that you're going to be using to make a statement for the problem or of the problem. Then you are going to be having the hypothesis, which a lot of persons like to say it's an intelligent guess, but it is your position on the research. Now, you can't have an hypothesis that you will not be able to test. So, you want to have an hypothesis. We're going to look at that as we go through the labs. Then the aim should be related to the hypothesis. So, what is it that you thought about what you're going to be doing? That's what your aim is going to be around. Material and apparatus are the things that you're going to be using in the lab to carry out the experiment. Then the method should also include variables. Now, it's not really necessary for you to say in the method or the procedure that this is the variable, but your teacher might ask you to do so. But any teacher marking a planning and design should be able to pick up whether or not there is a variable, a control variable, pretty much in the method. But it's good for you to outline them and make sure that you understand these clearly, because if not, you might see them on question number 1 of your paper 2 examination or the paper 032, and you are not able to answer questions like those. Now, the assumption, precaution, possible source of error, those are also supposed to be packed in nicely. And we're going to be showing you what is expected in this video. Now, expected results. What is it that you are expecting? If you're carrying out an experiment, then it's only logical that you have an idea as to where you're going. You might not get there, but of course, you should have an idea that this is what you're expecting. And if that's not the case, then you're expecting this. Part B is the implementation, which is, of course, the analysis and interpretation. You're going to be having an introduction. As is customary, the analysis and interpretation lab or any AI lab must have what we refer to as background knowledge or background knowledge to the problem. So you need to find out a little bit about what you're researching on, the importance and that sort of a thing, and all packed in the lab. Method linked to part A, just a change of tense. So it's the same method or procedure that you wrote in the planning and design that you're going to be writing in the implementation. Now, the results are going to be your observation from your implementation. So whatever you are implementing, you are going to make sure that you capture all the changes, all that can be seen, all that can be heard, so on and so forth, to ensure that that is all packed in the lab. Caution is pretty much explanations and interpretations that could also look at trend. I like to say it speaks to the which, where, why, when, and in some cases, the what. Limitations. What are those things that could have affected the experiment, preventing the results from being 100% accurate? And usually, these are things that you have no control over. You'd have tried your very best, but you are not able to control them. But these could pretty much impact the result of the experiment. That's your limitation. And then reflection again is that which you would have learned from your experiment. Conclusion, your final position. Based on what you thought, what is now the new knowledge gained from the experiment? Now we are looking at the planning and design and the detail marking of the planning and design. So for the hypothesis, if it's clearly stated, you will get 2. Clearly. If it is testable, you are going to get 1. And if you just write something that is not so much testable, you might just get 1. But if it is clearly stated and testable, you are definitely going to be getting your full marks for that. For the aim, 1 mark is allotted for aim, and it must be related to the hypothesis. For the material and apparatus, this is how it's broken down. You are going to get a mark for that. And of course, it must be appropriate material and apparatus. You're not going to be talking about some things that they use at NASA when you know you don't have these resources to carry out the lab. Method, you get 2 marks for the method. If it is suitable stated, you get 1 mark. At least 1 manipulated or 1 responding variable, you're going to get another mark, and that makes up 2 marks. Control variable, you get 1 mark for the control variable. And it's sort of difficult for you to write a lab where you are testing anything and you can't find yourself a control variable or a manipulated variable. You would not have had a lab if you were supposed to write one, and that is not included. Control variable stated. So yes, we know that this is a control variable. You're going to be getting 1 mark for that. The expected result, 2 marks, and you're seeing the breakdown there on the screen. Assumption, precaution, possible source of error. You're going to be getting 1 mark there. And then we move on down into analysis and interpretation. Now, B here shows how the marks are allotted for the implementation. So you want to make sure that you adhere to what's happening here. So just look at what's happening on the screen. Make sure that that pretty much satisfies the requirement of CXC when you would have written it up for submission. So there we go. The implementation is marked out of 20 and of course scaled to 10. Get help with CSEC Biology SBA Labs and Human and Social Biology SBA Labs at tcp-academy.com. Tim had questions. He wanted to know where he could get help with his SBA Labs. His parents searched but could not find that experience. Tim also made some calls, however could not find the help he needed. Tim needed an experience he could trust to help him get over the hurdle of SBAs as success was in sight. He met the guys from tcp-academy.teachable.com and they designed a program to help him. tcp-academy.teachable.com was able to help him. So too, they can help you. Sign up tcp-academy.teachable.com for help with your SBAs in biology and human and social biology.